Hi guys, welcome to COSC100 Tutorial 3, exercise number 5. So in this exercise, I've given you a more challenging problem. So this one's actually meant to be quite a bit harder than the other two. You're actually going to implement a one-dimensional version of Conway's Game of Life. Now if we jump onto the Wikipedia page for Conway's Game of Life here, you'll see that it's actually basically, it uses a grid arrangement. So here's an example of one playing out where each individual, where the state in a particular time step is dependent upon the previous state, and there's a set of rules that actually specifies how you transition from one state to another. So you can create all kinds of patterns. So if you start off with, in the case of the blinker or oscillating type patterns here, you can actually start off in one state and the rules actually specify how the movement takes place to the next one, so it actually alternates between the two states. So there's a set of rules that determine which cells effectively light up based upon the previous set of cells in the previous timestamp that lit up. So there's all sorts of patterns there that you can implement here. We're going to start off with a fairly straightforward one. I've given you a set of rules there. So we're going to use our spreadsheet to implement this. Now, in our arrangement, the rows in our spreadsheet, so each of the rows down the spreadsheet, are going to represent our time series. So it's going to be our steps in time. So we'll start off with time step 1, 2, 3, and so forth. And the cells across the page are going to be represent our state. So they're going to represent our different cells that are all neighboured and next to each other. So the values that are in cells in step 1 are going to determine the value of the cells when we move to step 2. Now, to implement this arrangement, we're going to be using the logical functions that we discussed at the end of lecture 6. So recall that the logical functions include the if function, the and function, and the or function. And that's all you actually need to implement this particular arrangement. So if we start off up here, if we look in step number 2, we can see that we've given you a set of transition rules. So in these rules, we've depicted them. We've used the cell arrangement to depict the rules. So you can see that if all of the cells in the neighbourhood, within the top 3, within the bordering 3 cells in the previous stage, are set to 1, the bottom cell actually is set to a 0. So this indicates that due to overpopulation, this cell has actually died. So if we think of 1 as the cell being alive and 0 being dead, if we have 3 neighbouring cells, so in this particular situation the neighbourhood is defined as the 3 cells directly above a cell, if they're all occupied or if they're all alive, that means in the next generation it's going to die. And so forth with these other cells. So you can see here if only 2 of the 3 neighbouring cells are alive, the cell will be alive. If only 1 is alive, then it'll die in the next one. So this represents sort of overcrowding and population. And you've got a couple of other curious rules over here that actually catch up, that actually indicate that. Now, we can actually go through and implement a set of rules using our if statement to capture that logic. So if we start by entering our first time step. So in this situation, I've given you the start configuration down here in the image below. You can see that we start off with 0, 0, 1, 0, 0. Now, we're going to start from the middle cell and we're going to start implementing our rules. Now, to get this kicked off, we need to use an if statement. So in this if statement, we're going to have a logical test, so some series of logical operations that we're going to test, and then if that logical test comes back as true, we're going to set our value to 1, otherwise we're going to set it to 0. So basically we're using the if statement in this situation to test if the cell is actually going to be alive. So now we need to start working with our logical statement. Now, if we look closely here, there are actually 4 configurations in which the cell will be alive in the second generation. So we can see here that if we have 2 cells either to the left or the right, in the above generation alive and 1 set to 0, that it's actually going to be alive, and we can see if one of them off to the side is alive, it's going to be alive. So basically we only have 4 configurations. So we can actually use an OR operation. So if it's this configuration, or this configuration, or this configuration, or this configuration,
then we can set it to alive. Otherwise, we have to set the cell to dead. So we have to set it from 1 to 0. So we can actually achieve this by using an OR operation. So we put an OR operation in there, and then we're going to actually have a series of AND operations. So here, if we want to capture the first configuration, we have an AND operation. So we go AND. So if in this AND operation, I need to get rid of the B out of there. So if, so we're going to actually implement this test here first. So we're testing if this cell is equal to 1 and this cell equals 1 and this cell equals 0, then that one's going to return true. So we've actually we've covered that case. Then we move to the next one. Okay, we're going to test the second configuration here. So if this cell, actually we'll need an AND operation, sorry. Put our AND operation in here. So again, inside the AND operation, oops, I haven't completed that properly. So inside the AND operation, if this cell equals 1, this cell equals 0, and the final cell equals 0, then that one will also result in the cell being alive. Now we need to go and implement this one down here. So again, we put an AND in there. So if we're saying that if this one equals 0, if this cell equals 1, equals 1, and this cell equals 1, then it's also going to be alive, and we only have one more configuration for this cell to do. So the next one, we're going to put in another AND operation. Click back again. So if this particular cell equals 0, if this particular cell equals 0, and if this particular cell equals 1, it'll also be alive. So if we go and hit enter on that one, you can see that we've actually implemented the formula for that first cell. So if we change this over and we change this one to a 1, you can see that that doesn't work. So what have we done here? We haven't implemented something correctly. Let's go back through and see what we've missed. You can see here that we've actually put in a plus sign instead of a comma. So you can see once we fix that up, that's got our configuration working, and we've captured all of the rules there. So that's got our first cell implemented. So now we need to go through and follow on with the same pattern for this one. Now we can fill this one across and see if it'll work. Let's see if that's fixed that up. So you can see that that's actually got that working now. So if we change that to a 1, that one's going to be alive. So remember that it's only these 3 cells that are going to be impacting the population of this one here. So these 3 cells determine the state of this one. So if we put a 1 into here, it should change to 0. If we put a 0 into here, it should also change to 0. So we've captured all of those different configurations in our sheet here. I'm actually going to go in and put some conditional formatting on so that we can see our living cells. So now if we go in and we put a 1 in here, see we've captured the pattern that we need to have in order to bring our cells to life. So these 3 cells here are determining this one. You can see that they've captured this pattern here, so it's alive. Now we can build this up. The only tricky thing that happens here is once we get to the end cells, they actually draw their value by wrapping around. So this cell here will be determined by these 2 here and also this one at the end. So basically, instead of relying on this cell over here, we wrap it all around, and we put our references into that one. So we do that by just jumping into here. You can see here that they'll refer to empty cells. So if we go and have a look here, we just change all of the B references to G references. So if we change that one to G, we'll change all of the references to G in here, which should be all of these ones.
That should sort out all of our empty references. That should get us back to where we're working now. So that looks pretty good, and we'll do the same on this end. So again, this cell here is going to depend upon this cell, these two cells, and this one to determine its next state. So in here we'll go and change all of the H references to C references. So you can see it's going to be determined by cell C2 here. So all of the H2 references need to change, and we change that to C2. Oops. C2, C2, and last of all C2. So now we've actually completed our set of logical rules. So now it's time, and we can already see that we're starting to get the pattern that we want, but now we're going to test our configuration. So we just grab the fill handle and we fill down. Now you can see that have we got the right pattern? I think we have. It just looks a little bit different because my cells aren't as wide as they are. So if we go and fix this up, you can see there, ooh, a sec, that one needs to go there, make that one a little bit slimmer. So you can see that we've actually created the correct pattern that we're after here. So let's make those auto width. Actually, there's a really simple way that we can do that. We can go format, column width, oops, auto format, sorry. We can auto fit our column width here, and you can see that we've created the T pattern that we're after as we move down. So that's how we implement a simple one-dimensional version of Conway's Game of Life. Now you can actually alter these rules up in here to implement different state transitions. So if you change them slightly, you'll get completely different patterns. So run through and have a look at your understanding of that demonstration. That's probably the trickiest problem that you'll face in this one. And it allows you to essentially do some programming, some end-user programming in your Conway's Game of Life. So if we alter the first generation, you can see that it alters the overall pattern. If we have ones all in the first one, you see it kills off the entire generation as we move through. So very interesting, and have a play around with that one in your own time. So make sure you review my example. I'll put my example up for you to have a look at. And that's probably the most challenging problem that you'll have to deal with in Excel. So thanks guys, and thanks for listening.